Hey guys, so I just got my hands on the Mathematical Methods Exam 1 2024, so without further ado, let us get started. I haven't done this paper before, my first look, so if I do make any mistakes, just let me know. Okay, so y is this, and we have to find dy dx. It's a one marker, so we are not expected to show the working out, but rather the direct answer will do as well. So dy dx, we just use simple product rule, so ex cosine 3x minus 3ex sine 3x. Okay, that should be our answer. So let fx is this, we have to find this. So 2 marks. I'm assuming that 1 mark is for the correct derivative and the second mark is for the correct value of this. So let us quickly find that. So, oh yeah, with the log, whenever you have something like this, log of f of x, our answer will always be, and you have to differentiate this, say for example, like in this format, our answer, so once we differentiate it, we always get f dash of x over f of x. Always. This is a secret, not a secret, but rather a trick to, so this is like a trick to differentiate these type of functions quickly. And if you want to know the proof and stuff, just go to one of my shorts. I've explained it there. I'll link it down in the description below as well. Okay, so using this trick, let us quickly differentiate. So that is simply going to be 3x squared minus 3 over x cubed minus 3x plus 2. Okay, and then you have to substitute 3 in, so 3 times 9 minus 3 over 27 minus 9 plus 2. So 27 minus 3 is 24, and 27 minus 9 is 18, plus 2 is 20. So it's going to be 6 on 5. Okay, so that is going to be our answer. Alright, moving on to the next question. So we got consider the simultaneous linear equations where x and y is a real constant. Okay, determine the value of k for which the system of equations has no real solution. Okay, so basically when these two lines are parallel, that's what we have to find. So for what value of k are these two lines parallel? Okay, so first I'm going to make y the subject for both of the equations. So for this question, I'm going to say that this is my equation 1 and this is my equation 2. So let's start by making y the subject for equation 1. So we have 3kx minus 2y equals to k plus 4. So minus 2y is equals to k plus 4 minus 3kx. So y would then be minus k minus 4 over 2 plus 3k on 2x. Yep, that's correct. Okay, so the second equation, so k minus 4x plus ky is equals to minus k. So ky is equals to minus k minus 4x, and y would be minus 1 minus k minus 4x divided by k. Okay, so now we just have to make gradient the same. So 3k on 2 is equals to minus k minus 4 on k. Oh, sorry, brackets, forgot. Okay, then we'll have 3k squared minus 2k equals to minus 2k plus 8. So 3k squared plus 2k minus 8 is equals to 0. So 24, so we need 6 and 4, so 3k plus 6k minus 4k minus 8 equals to 0. So 3k squared, 3k, we take the 3k out, so k plus 2 minus 4k plus 2 is equals to 0. So 3k minus 4, k plus 2 is equals to 0, so k is equals to 4 on 3, and k is equals to minus 2. Okay, so usually with these questions, one of them will be incorrect. So what I'll quickly do is quickly check whether both of them are correct or incorrect. So let's substitute the values in. So check, okay, check k equals to minus 2. So substituting k equals to minus 2 in equation 1 and then equation 2 to see which value is correct and which isn't. So minus 6x minus 2y is equals to minus 2 plus 4 is 2. Now the bottom equation, minus 2 minus 4 minus 6x plus, minus 2y is equals to 2. Well, so this is for infinite solution. As you can see from the equation, this is for the infinite solution, so k cannot be equals to 2. So that means k cannot be equals to 2. Minus 2, sorry. Okay. Now, check k equals to 4 on 3. Now, usually this is going to be the correct one because I've never seen a question or case where both of the answers we find are incorrect. If that's the case, you better check your working out again. So let's quickly check these values as well. So first equation, putting that in the first equation, we'll get 3 times 4 on 3. So 4x minus 2y. And then we have k plus 4. So 4 on 3 plus 4. So that's 16 on 3. Okay, cool. So is equals to 16 on 3. And for this one, so we got 4 on 3 minus 4, so 12 minus 8 on 3. Okay, so minus 8 on 3x minus plus 4 on 3y equals to minus 4 on 3. Sorry. Okay, so if you were to multiply this by 3, so minus 8x plus 4y is going to be minus 4. So let us divide this by negative 2 as well, just to simplify it more. So we get 4x minus 2y is equals to 2. Oh, sorry, wait. Yeah, I mean divide by negative 2. Yeah, sorry. Did I say negative? I think I did. Okay, anyway. Yeah, so there we go. So this and this, as you can see, indeed have the same gradient, but they are parallel now, but they're not like exactly the same. So same gradient but not exactly the same, so they're parallel, which is what we want. So then k is going to be equals to 4 on 3. That's going to be our answer, and we reject k equals to minus 2. Okay, so that's that. Moving on to the next question. So we got a function g of x, looks like a truncus. On the axis below, sketch the graph of this, labeling all the asymptotes with their equations and x-intercept with their coordinates. Okay, so asymptotes are pretty easy to find, so let's just quickly draw them out. So x equals to minus 3 is going to be one of them. Also, just make sure that asymptotes are like this and not like a straight line. Okay, so that's our first asymptote. The second one is just y equals to minus 2. Okay, so y equals to minus 2. Make sure you labeled them as well, or else that's going to be marks gone there. Okay, so we have done the asymptotes. So asymptotes is checked. Now we have to do the x-intercept. So starting by finding the y-intercept. So x is 0, so 1 on 9 minus 2, which is negative 17 on 9. So that is just less than negative 2, so it's going to be somewhere here. Now we solve for the x-intercept, so set y equals to 0, so we get 1 on x plus 3 squared is equals to 2. Yep. Then we have x plus 3 squared is equals to half. So x plus 3 is going to be equal to plus or minus 1 on square root of 2. So x is going to be minus 3 plus or minus 1 on square root of 2. Okay, so 1 on root 2 from just general knowledge is going to be equal to like 0.71 roughly. So it's going to be, one intercept is going to be minus 3.71, which is roughly somewhere here, and the other one is going to be 3 minus 3 plus 0.71, so that's like 2.29 about. Yeah, so 2.29, I think. Yeah, okay. So I think that's gonna be somewhere here. Okay. And oh yeah, I'll do one more point as well. So what I mean by that is our graph can currently go like this, our graph can currently go like this as well. Doesn't really matter. But to get the scaling right, what I'm going to do is I'm going to substitute in another point, which is not the most important one. So any other point than the axial intercept and the asymptotes or whatever. And then see where the point is. So say for example, here I'll substitute in -4. So why -4? So then this will become 1 and it will be easier for us to calculate. So g of -4 is going to be equal to g of -2 as well. So g of -2, I believe, which is going to be 1 on -4 plus 3 is -1. -1 squared is 1. So 1 minus 2 is just -1. So -1. So our values are going to be here and here. Okay, so that is our truncus. So let us plot that. Like that. And this side is going to be hard one. Is that in domain? No. Okay, so we have to draw another arrow. Okay, like that. And something like this will do. Oh, this looks like a linear line. Let me maybe try again. Okay. No, that wasn't any better. Okay, I'll just keep this. Okay. Yep. And now let us label our axial intercepts. So this one is 0 and -17/9, and this one is going to be -3 plus 1 on √2, 0, and this one is going to be -3 minus 1 on √2 and 0. Done. Okay. These points are like just random points I chose. You don't have to label that if you don't wish to. Okay. Alright, so I guess that's it for this. So we only do axial intercepts and the asymptotes. We have done that. Okay, so I think that's good. With the marks distribution, 2 marks for, so 1 mark for the correct axial intercept, 1 mark for the correct y-intercept. So 1 mark for x, 1 mark for y, and 1 for the shape is what I think is how they do it. So just a disclaimer, guys. So the marking thing that I'm saying or suggesting is like a suggested marking scheme. It is not the actual one. It could be, I'm not too sure, but I could be very well wrong with how they mark it. So do not exactly quote me for that. I'm purely basing this on logical assumptions, okay? So yeah, do not actually quote me on this marking and how it goes, okay? Just saying. Alright, so moving on. Determine the area of the region bounded by the line x equals to -2, the x-axis and y-axis, and the y of this, and the graph. Okay, cool. So then what I'll do, I'll quickly draw another line. So x equals to -2 right here. And the area that we are finding is basically this. Just this one. Okay. Yep, so we are just finding this area over here. Okay, so let us set up our integral for this. So we'll have our area is going to be from -2 to 0, 0 minus gx, because the y equals to 0 line is above the graph, and in this set of range, in this set of x values I should say, dx, which is going to be the same as -2, okay, so yeah, which is going to be the same as that. Alright, so minus, and now substitute the things in. So 1 on x plus 3 whole squared plus 2, oh sorry, minus 2 minus 2 dx. So we got negative, let's just integrate this. I don't think we need to simplify it anymore. Okay, let me change my eraser. Okay, there we go. So integrating this, we'll have negative 1 on x plus 3 minus 2x minus 2 and 0. So that will give us negative 1 on 3, which is the first term, and take away. So minus 1 over minus 2 plus 3. So that is simply going to be negative 1. So negative 1 plus 4. Okay. So then we'll have negative 1 on 3. Remove the brackets actually. Negative 1 on 3 plus, so minus 3. So this will give us minus 10 on 3, and hence our answer is going to be 10 on 3. Okay, so this is the answer for this question over here. Okay, marking schemes. This is 2 marks, so 1 for the correct working out, and 1 for the correct answer. Okay, so let's move on to the next question. Okay, so this is a probability question. So let x be a binomial random variable where x is this. Find the standard deviation of x. Okay, let me pull up my formula sheet real quick. Okay, so from the formula sheet, the standard deviation, just say that, okay. So standard deviation is just going to be square root of NP, 1 minus P. So we'll have square root of 4 times 9 over 10 times 1 minus 9 over 10, so 1 on 10. So we will get square root of 36 on 100. So that will be 6 on 10, which will indeed be 3 on 5. So that is going to be our answer for this case. And the next thing we have to find is probability that x is less than 2. So probability that x is less than 2 is the same as probability that x is equals to 0 plus probability that x is equals to 1. Okay, so let's find probability that x is equals to 0 using the NCR formula. So we have 4C0 and then times by 9 over 10 to the power of 0. So that's just going to be 1. Just keep it anyway. 1 over 10 to the power of 4. So that would result in 1 over 10,000. Probability that x is equals to 1 will be 4C1. So in this case it will be 9 on 10 to the power of 1 times 1 on 10 to the power of 3. So this case would be 4 times 9 on 10,000. So 36 over 10,000. So therefore, probability of x is less than 2 is going to be equals to 36 on 10,000 plus 1 on 10,000, which is indeed going to be 37 on 10,000. Okay. So yeah, that's that for this question. Again, marking scheme, 1 mark is always for the correct answer, is what my assumption is. And the other part would maybe be setting these two up, is my assumption. Okay, moving on to the next question. So question number 5. Okay, so the function h of t models the population of a town after t years. Okay, use the model ht to predict the population of the town after 4 years. Okay, pretty simple. We just substitute t as 4. So 3,000 over 4 plus 1, 5, so 600 people. Okay, there you go. 1 mark, correct answer, I guess. A new function, h1 models a population where h1 of 0 is equals to h0, but h1 decreases at half the rate of h at any point in time. State a sequence of 2 transformations that maps h to this new model h1. Okay, so this new model is decreasing at half the rate. So the y value is changing half times less than h, is essentially what we are saying. So y value is halved like the speed is halved. So that means if y value is changing, we have to dilate by a factor of half from the x-axis, or well, the t-axis in this case. So I think one of the transformation would be dilation factor of half from t-axis, and because it's half, we have to increase the starting point as well, or else it's not going to be the same. So the next one is going to be translation of 1500 units in the positive direction of x, well, not x-axis, what am I saying, of, no, not y, even h-axis. I think this should be correct. Okay, so the next question. In the town, 100 people were randomly selected and surveyed. Okay, so 100 people, and with 60 surveyed, with 60 people indicating that they were unhappy with the roads. Fair enough. Determine approximate 95% confidence interval for the proportion of the people in the town who are unhappy with the roads. Use z equals to 2 for this confidence interval. Okay, in that case, we just have to first of all find the value of p hat, which is pretty obvious. So p hat is simply going to be 60 over 100, which is 0.6. And our confidence interval will have the formula. Let me just quickly see the formula sheet. So yeah, here we go. So formula would be 0.6 and then minus 2. So it'll be 0.6 times 0.4 divided by n. So n is 100 people, and then same thing, but we add it now. So plus 2 times 0.6 times 0.4 over 100. And then that. Okay, so actually let me convert this into fraction, because, well, I mean, it's easier to simplify fraction than using the decimals. So I guess that will do. So this will be 3 on 5. So, I mean, if you don't know how to convert it, I just usually, so 0.6 will translate to 6 on 10. So that would give us 3 on 5. Okay, so that's how I convert it. And 0.4 is going to be 4 on 10. So 2 on 5. So that's how I do it. Okay, minus 2. Actually, the 100 will just simplify to 10. So 3 on 5 times, what is it? 2 on 5, right? Yeah. Divided by 100, or 10, sorry. Just simplified it out of square root. So 3 on 5 plus 2 times 3 on 5 plus 2 on 5 over 10. Okay, so I guess we can cancel this out. Cancel this out as well. Sorry, not plus. What am I doing here? Okay, multiply. There we go. So 3 on 5, take away 6 on 25. So that will simplify to 6 on 5. So square root of 6 on 5 divided by 5. So it's 25. Root 6 over 25. And then 3 on 5 plus root 6 on 25. Okay, so I think this should be the answer for our confidence interval. What are the marking scheme? Yeah, so 2 marks, 1 for working out, maybe one mark for maybe this, finding the correct p hat value, and then the other mark would be for this, maybe. Okay, so moving on to the next question. A new sample of n people results in the same sample proportion. Find the smallest value of n to achieve a standard deviation of root 2 on 50 for the sample proportion. Okay, so since we have a sample proportion, our standard deviation is going to be 0.6 times 0.4 over, what are we finding? Yeah, n, so over n. So we don't have the number of samples, we have to find that out so that we can have a standard deviation of root 3 on 50, or root 2 on 50, I mean. So again, in that case, what I'm going to do, I'm going to simplify this. So 6 on 25n is equals to root 2 on 50, and then I'm going to square both sides, so square both sides, so 6 on 25n is equals to 2 on 2500. So n is going to be 2500 times 6 divided by 25 on 2. So this will give us 100. This will cancel out for 50. So n is going to be 50 times 6, which is 300. There you go. Alright, so next question. And how much marks? 1 mark. Okay, well, you know, it's just for the answer. Okay, so moving on to the very next question. So this is about log. So solve this for x. Okay. So we can apply log laws, as we can see straight away. So let us simplify the equation so we can use that. So take the 2 on the top to the power plus log base 3 of x is equals to 2. Now we can times it. So log base 3 x times x minus 4 squared is equals to 2. So x times x minus 4 squared. Yeah, okay, good. I thought this was like cubing for a second. Okay, 9. So because that's like 3 squared, so 9. Okay, so now I guess we just simply expand this. So x squared minus 8x plus 16 is equals to 9. So x cubed minus 8x squared plus 16x minus 9 is equals to 0. Guess we have a cubic to solve. Let's just use the guess and check method. So I'm going to try x equals to 1 and see what happens. So x equals to 1 when x is equals to 1. So 1 minus 8 plus 16 minus 9. So that will be minus 7 plus 7. Okay, well, that was pretty easy. So our x minus 1 is a factor. So now I guess we do the long division. So x minus 1, x cubed minus 8x squared plus 16x minus 9. So x squared, x cubed minus x squared minus 7x squared plus 16x. Okay, then this will give us 9x minus 9. 9x minus 9. Okay, so then we have our two equations that we can, well, not two equations, I mean, now we have like a factorized form. So x minus 1 and x squared minus 7x plus 9 is equals to 0. Alright, so from just this we can clearly see one of our solution is going to be x is equals to 1. Okay, there you go. So x is equals to 1 is one of our solution, but we have to reject it. The reason being that if you put x equals to 1 in here, this part becomes undefined, so we can't have that. So what we'll do is we'll just write it down that, well, okay, it's switched by itself. X is not equals to 1. X cannot be equals to 1. Reject, else function is undefined. Function else, yeah, function is undefined. Function is undefined. Is undefined. Okay, we rewrite that. Is undefined. There we go. So now let us solve for the other part. So can we actually factorize this first? 9. So it's going to be 3 and 3 or 9 and 1. Now, okay. So solving x squared minus 7x plus 9 is equals to 0. So just a note. So x is going to be negative b. So negative, wait, no, positive 7. Yeah. Negative b plus or minus b squared. So 49 minus 4ac. So 4 times 9 times 1. So minus 36 divided by 2. So that will result in 7 plus or minus square root of 13 over 2. So our x values are 7 plus square root of 13 on 2, and x is equals to 7 on 2 minus 13 on root 13 on 2. Okay, so let us quickly check whether both of them is going to satisfy the equation. Okay, so 7 on 2 is 3.5. So 3.5 minus root 13 on 2. Yeah, again, because 3.5 is already less than 4, we need something more than 4. So this is definitely going to be rejected again because it will make the function undefined. So we'll say again, x cannot be 7 on 2 minus root 13 on 2. Reject, else function is undefined. I'm just going to say function like this is undefined. Is undefined. Okay. So our only answer is x is equals to 7 on 2 plus root 13 on 2. That is the only answer that is valid. Everything else is invalid for this case because it doesn't satisfy this term over here. Okay, so how much is it? Oh, 4 marks. Okay, well, I'm definitely sure. Well, not no. Maybe I'm like 50% sure that this is the rejection, rejecting the wrong answers will give you 1 mark. 2 marks is maybe for the working out, so identifying that this is the factor and then getting another factor, so maybe this will have 1 mark, this will have 1 mark, then rejecting the correct values will have 1 mark, and the final answer will have 1 mark. So that will make up the 4 marks according to my assumption. Okay, so let's move on to the next question. Okay, so part of the graph f of x is shown below. Use the trapezium rule with a step size of pi on 3 to determine an approximation of the total area of y equals to fx and the axis over the interval 0 pi. Okay, so for this we can just simply use the area of trapezium. So we'll just say that area, actually I'm just going to write it like this. So area of trapezium is going to be half a plus b times the height. So let us start. So therefore the area is going to be half times f of 0, because that's where everything starts from, plus f of pi on 3, so f of pi on 3 times by pi on 3, plus half times f of pi on 3 plus f of 2 pi on 3, and times that by pi on 6 as well, and then add 1 on 2 times f of 2 pi on 3, sorry, 2 pi on 3 plus f of pi, doesn't need long bracket, just f of pi, times pi on 6. Okay, so, oh wait, pi on 6, what am I doing? Pi on 3, where am I getting pi on 6 from? Wait, pi on 6, pi on 3, okay, good. Alright, so, yeah, I guess we just simplify, so therefore our area is going to be f of 0 is going to be 0. Actually, I know where the pi on 6 came from. I was just multiplying pi on 3 by half in my head. So, okay, I guess that makes sense. So pi on 6. So f of 0 is just 0. F of pi on 3. So pi on 3 sine pi on 3. So pi on 3 times root 3 on 2. So root 3 pi on 6. So root 3 pi on 6 plus pi on 6 root 3 pi on 6 plus f of 2 pi on 3. So 2 pi on 3, the value wouldn't change because it's in second quadrant, so it wouldn't change. So this and this will cancel out, so root 3 pi on 3, root 3 pi on 3 plus pi on 6 root 3 pi on 3 plus f pi is just going to be 0 again. Coolio. Okay. So we get root 3 pi squared on 6 plus this one would be 3 root 3 pi on 6, so 36, and then this one would be root 3 pi wait, this one is squared as well on 18. Oh, this one is 36. Okay, so I guess we just make the denominator the common one, so that would be equals to root 3 pi squared on 36 plus 3 root 3 pi squared on 36 plus 2 root 3 pi squared on 36. So that will be 6 root 3 pi squared on 36. Okay, so that would just become root 3 pi squared on 6. So root 3 pi squared on 6. So this is going to be our answer. 3 marks, again, 2 for working out, 1 for the final actual answer. Okay, so now we have to find the derivative of f of x. What is our f of x again? X sine x. So again, we can just use product rule. What's the mark? So 1 mark, just its direct answer. So it will be sine x plus x cosine of x. Okay, I think that's it. Determine the range of f dash of x over the intervals of pi on 2 to 2 pi on 3. So if I were to look back at the graph, so we do pi on 2, so it's somewhere here. 2 pi on 3, 2 pi on 3, so here. Okay, so what this information tells us is that there won't be any stationary point between these two values. The reason being that, there is a stationary point right here, which is at 2 pi on 3, but not in between. The reason why this is important is because this graph could have very well been something like this, where this is pi on 2 and this is maybe this is 2 pi on 3. So if you just want to substitute the endpoints pi on 2 and 2 pi on 3 in the derivative function, we won't get the accurate range. So that's why I went back to check whether there is any stationary points that are in the between which could affect our answer. But since there are none in between but rather at the end, we don't have to worry about that, and we can just simply substitute the endpoints to obtain our answer. Okay, hopefully that made sense. So our f of f dash of pi on 2 is going to be sine pi on 2 is just 1 plus cosine pi on 2 is 0, so that is equals to 1. F of 2 pi on 3 is going to be sine 2 pi on 3, as discussed earlier, it's root 3 on 2 plus 2 pi on 3 times by negative a half, because second quadrant cosine is negative, so we'll get negative pi on 3. So minus pi on 3. So our range is equals to root 3 on 2 minus pi on 3 to 1. Okay. Hence verify that f of x has a stationary point for this. Okay. Verify that f of x has a stationary point for this. Okay, very well. So we have the range of our derivative function for this particular given domain, which matches what we have here. So if our range is going to be this, right? When would we have a stationary point? If, let's say, our range was 1 to 3, for example, would this have any stationary points? No, it wouldn't, because it doesn't have a 0. However, if we had like negative 1 to 3, this would have a stationary point, because y value between these 2 points is going to become 0 at one point, right? So that means all we have to do is to prove that this value over here, like this term over here, is going to be less than 0. Because again, whenever we are solving for derivative, if you remember, we always differentiate the function first. Sorry, whenever we are solving for the stationary point, we first differentiate the function and then we set it equals to 0. So if we are setting f dash of x is equals to 0, we obtain the stationary point. So basically, if f dash of x is not 0 in the given range, which is this over here, that means no stationary point exists. But if there is a stationary point, derivative of f of x will equal to 0 at least at one point. So what we have to do is to prove that this is a negative value, if that makes sense. Okay? Alright, so how would we do this actually? So this is going to get a bit messy, I think. So let's start by actually simplifying this. So this will also count as 3 on 2 root 3, right? So this will become 3 on 2 times 1 on root 3. So 1.5 times 1 on root 3. Okay, so now root 3 will be very close to 1.7. Why did I say 1.7? The reason being, if you guys remember, 17 squared is 289, which is quite close to 300. So in this case, 1.7 squared will be 2.89. So square root of root 3 is going to be slightly bigger than 1.7. So 1.74, 1.73, somewhere around there. So what I'm going to do is I'm going to say that we are timesing 1.5 times 1 on 1.7. Just a rough value for root 3. Not the exact one, of course, but just a rough one. So now we have to find out what this is going to be. So this is the same as writing 10 on 17. So, sorry. If I were to divide this, we'll get 0 and then 0, so 100. And then we have point, so 17, 6 I think would do it. So that will be 102. Okay, so it's going to be roughly 0.6 but less than 0.6. So 0.6 of 1.5. So 0.6 of 15 over 10 times 6 on 10. So that's like 90 on 100. Okay, so we can then say that root 3 on 2 is roughly equals to 0.9. Just a rough estimate. So what I've done here, I've just simplified all of the expressions down here, if that makes sense. So 1.5 can become 15 over 10. And 1.7, which is indeed 10 over 17. And I've simplified that to this. So 0.6. So 1 over 1.7 will give us 0.6. This is 6 on 10. As you can see, I've listed here. And I've just simply multiplied them to obtain like a rough estimate of what root 3 on 2 will be. Okay. Now, we do the same thing for pi on 3. So if pi on 3 is greater, if pi on 3 is greater than 0.9, which it is, because 3.14 is pi, divided by 3 is going to definitely give us 1.04 something something something. So from this we can determine that root 3 on 2 is going to be less than pi on 3, and hence there will be a point where, okay, let me erase all of this out. I'm going to run out of space. Hopefully all of this made sense to you. I'm just basically simplifying the square roots because I don't know what could be a better approach than this. If you guys have a better approach, just let me know down in the comments, okay? I'm always looking for better way to do things with maths, so please let me know. Okay, hence there will be a point where f dash of x is equals to 0, which results in a stationary point, Okay, right? Okay, so on the set of axes below, sketch the graph of y equals to f dash of x on the domain this, labeling all the endpoints with their coordinates. You may use the fact that the graph of this has a local minimum approximately as negative 1.1, so somewhere here, and negative 1.4, so like somewhere here, and 1.1 and 4, so somewhere here. Okay, what other points can we actually tell? Okay, so if this is the graph of y equals f of x, these are going to be our stationary points here and here. So that means our derivative will have the x-intercept right here underneath and here. And our endpoints are given to be this. So what was our derivative function? I think it was sine x plus x cosine of x, I believe. Yeah, okay. So our f dash of negative pi is going to be 0, yep, minus pi. Cosine of negative pi is going to be negative 1, so this will indeed become positive pi, so that will become positive pi, and f of pi, again, the sign would be 0, f dash of pi would be 0, plus pi times cosine of pi, which is again negative 1, so this will result in negative pi. So end coordinates are going to be somewhere here and here. Okay, so let us graph. Okay. Alright. Something like this would do. I'll probably lose a mark for a shape here because this not good, and also there's like a slight wobble and stuff, unless like they're not strict with marking, but most likely I'll probably lose a mark for a shape here. So let us quickly label the points. I don't want to lose any marks for that. Labeling the endpoints with the coordinates. So one thing that we will label is the end coordinates, which is going to be negative pi and pi and pi and negative pi. And of course we'll label all the x-intercepts as well, just because why not. And this one would be negative 1.1 comma minus 1.4 and 1.1 comma 1.4. Okay, I just want to be safe and not lose any marks for this. Okay, so that's that. Let's move on to the next question. So question number 8. So we have gx is equals to this, where k is every other value but not 0, and m is all real numbers. And let point B be the y-intercept of the graph this. Okay, find the coordinates of P in terms of k and m. Okay, so for this, if it's just a y-intercept, we have to set 0. So set x equals to 0, I mean. So we'll have negative k to the power of 1 on 3 plus m. So this is just another way to write cube root. So our coordinates for P would be 0, comma, negative k to the power of a third plus m. Okay, find the gradient of g at P in terms of k. Okay, so we can express g as x minus k to the power of a third plus m. And now if you were to differentiate it, we'll get 1 on 3 times by x minus 1 to the power of minus 2 on 3 times by differentiate the inside in terms of x with respect to x, we'll just get 1. So ignore that. And plus m is a constant, so that wouldn't matter. Now, we have to find the gradient of g at point P. So when x is equals to 0, basically, we have to find the gradient then. So 1 on 3 times negative k to the power of negative 2 on 3 is going to be the gradient. Okay. Well, okay, this one is 1 mark, so probably correct answer. This one is 2 marks, so differentiating and correct answer. Okay. Given that the graph y equals to g of x passes through the origin, express k in terms of m. Okay, well, so there is one coordinate, so they're basically telling us g of 0 is 0, essentially. So that would mean that x minus k to the power of 1/3 plus m is equals to 0. Oh, sorry, hold on, my bad. X is also going to be 0. So that, then we'll have minus k to the power of 1/3 equals to minus m. So minus k, now I'm going to cube both sides. So minus m cubed is still going to be minus m, is equals to minus m cubed, sorry, yeah. Yes, it should be minus m cubed. So k is equals to m cubed. Okay, so 1 mark for correct answer, I guess. So let point Q be a different point from the point P, such that the gradient of G at points P and Q are equal. Given that the graph of y equals to gx passes to the origin, find the coordinates of Q in terms of m. Okay, so what they're basically saying is, okay, so let's say that I'm going to take Q as x and g of x, okay? So now, if I want to find the gradient at Q, how would I do that? So g of x is equals to the equation that we have in terms of x already, which is just this. So if I want to find a gradient at point Q, which could be any point, so I've just called it x and g of x, it is simply just going to be this over here, right? Because if it could be any point, I'm just saying that x and g of x. So x and y are my x and g of x. So it could be just any point. So basically what they're asking for is point Q, as I said, is just x and g of x. So our gradient at point Q is just going to be the function itself, the derivative function itself. So 1 on 3, x minus k, 2 on 3, okay? And that has to be the gradient at point P. So this basically, so g dash of x has to be basically equal to 1 on 3 minus k to the power of minus 2/3. That's all they're asking us. So let's quickly solve this. Okay, so where's my equation? I'll just copy and paste this just to save time. Copy and paste. Okay, I don't need that. Alright, so that means we'll have this is equals to 1 on 3 minus k to the power of minus 2 on 3. Oh, wait, sorry, the m wouldn't matter here. It's a constant, my bad. Okay, there we go. I think that's better. And I think this would be, wait, what did I even copy? I copied the wrong function, no wonder. Okay, sorry guys, my bad. Because this looks so much like g of x. Okay, I'll just write it down. 1 over 3 x minus k to the power of 2 on 3 is equals to 1 on 3 minus k, that. Have I written it correctly? Yes, I have. Cool, so I'm going to multiply this by 3. That's the first thing I'm going to do. So x minus k to the power of this is equals to minus k to the power of that. Okay, so I can also express these as 1 on x minus k squared to the cube root. So same as k, so it will be k squared and 1 on 3. So, well, so negative k squared is just k squared, right? So that's what I've done here. Okay, so now what I'm going to do is I'm going to cube both sides. So cube this and cube that, because 1 cube is just 1. So 1 on x minus k whole squared is equals to 1 on k squared. So we got k squared is equals to x squared minus 2kx plus k squared. So x squared minus 2kx is equals to 0, because this and this would cancel out. So our x is going to be, sorry, I factorize it, so x minus 2k is equals to 0. So x is equals to 0 or x is equals to 2k. Alright, so if you substitute that back in, so x equals to 2k, what do we get? Where is our equation at? So we get 2k minus k to the power of a third plus m plus m. Okay, so this would be k to the power of third plus m, I think. Yeah. Okay. Are we missing anything? Given the find it. Oh, in terms of m. Oh, okay. Well, okay. In that case, so I'm going to say 2k and k to the power of 1 on 3 plus m is our coordinate, which is equal to k is what? K is m cubed, so 2m cubed and k cubed, so that is just going to be m plus m. So k 1 on 3 is just m. Yeah. Okay, so that is just going to be 2m. So 2m. So then, yeah, okay, so I think this is going to be my answer. So any more questions? No. Okay, well, that concludes the suggested solutions for 2024 Methods Exam 1. Hope you guys found it useful, and yeah, if I've made any mistakes, definitely let me know, because this was my first time doing this paper, so highly likely I may have. But thank you guys for watching. All the best for your Methods Exam 2 tomorrow. Wishing you all the best and hope you guys do well. Thank you. Bye.